Everyone. My name is Amreesh Phokeer. I work at the Internet Society as an internet measurement and data expert. And
recording in progress.
I'm a member of the Manus team. I would like to welcome you all. So good morning, good afternoon, and good evening, depending on where you are joining us from. Today is day 2 of the RPKI week, and today we are going to give you an overview of the different research projects we are working on, and also the different tools that we have been developing for our research initiative. So let me just give you an overview of the agenda today. Let me share my screen quickly. All right. So today we are going to talk, first of all, I will tell you a little bit about the Manus research work that we are doing. And my colleague Max Stucchi, who is here today, will talk about a tool we have worked on called the SHMIT tool, Shutdown and Hijack Measurement Identification Tool. Then he will tell you a bit more about a route collector that we have also been developing in-house that will help us understand better what the Manus participants are doing in terms of filtering and things like that. Then myself, I'll be presenting another tool that we have developed in-house called the ROA Historical Explorer. So how to go back into the past and see what are the ROAs that have been created by the different RIers, and see we will see how this tool can be helpful when doing troubleshooting. Then our colleague Mingwei Zhang, who works at Cloudflare, will tell you a bit more about another tool, another API based on the BGPKIT. So this one is a Python-based API, so called PyBGPKIT. And finally, we'll end up with a talk from Massimo Candela, who works at NTT, and he will tell you a bit more about RPKI operations and the different caveats of RPKI in a one-year review that he will do, and he will talk about an interesting tool that you should all use called the BGP alert. So without further ado, let me ask my colleague Max to talk a little bit about SHMIT tool. Over to you, Max.
Hello, everyone. Give me 1 second so I can start the presentation here and I can start sharing it. And here we go. So, Amreesh already introduced me. I'm Max. I work at the Internet Society. And as you could hear, I live close to an airport. So I have planes flying over my head all the time. And they hopefully will not disrupt the presentation that much. So today I'm going to give you 2 different presentations about 2 different tools I've been working on together with other colleagues. The first one is SHMIT, which comes from a need in different projects. So it didn't start fully as a project for Manus dedicated. The initial need was to have a tool to chase internet shutdowns because they represent a big part of sort of, let's call it, investigative work that we do at the Internet Society. We have a small dedicated team that chases internet shutdowns. And most of the work there, still now, because we haven't fully put SHMIT into production, is done manually, which means that we have places where we go and look for other people who have seen shutdowns happening in certain parts of the world, in a country, in a region. And from there, we start the process of figuring out if it's something worth examining further, exploring. So that is one thing. And the other one was to have better insights into hijacks. Shutdowns and hijacks sometimes are done, well, are seen in the same way. So there are changes in BGP that happen. Some peers get turned off, or there is a sudden large number of changes in BGP routing, in updates. So the idea that we came up with was, let's check if there are products that do this already. And of course, there aren't. There isn't something ready-made that you can just turn on and use for this. So we decided to try working it out on our own. And so, And so we came up with this idea, SHMIT. This is the name we have right now. I don't know if it's going to change, but the idea was, let's take something, the concepts from BGP Alerter. Massimo is going to tell you more about it later. But the idea was to have something that also would take information about all the ASNs in the AS path when we receive an update, rather than only the origin. This is made so that we look at everything that's happening in every single update we receive. Built using Python instead of JavaScript, because I'm not really fond of JavaScript, and Massimo knows it. And then we're leveraging async IO to get different parts of the tool to talk to each other. So how does this work? We have the core SHMIT that gets, first of all, IRR data. So we have a process that takes that downloads all the data from almost all of the well-known IRRs, all the regional registries, plus AltDB, RADB, NTTCom, all the sources you see also in BGPQ3 and BGPQ4. We take RPKI data, so we have a built-in library that runs RPKI RTR. And with these two sources, we build an internal database that's basically internal radix tree, one for IRR data and one for RPKI. So the idea of integrating them directly into SHMIT is to make it very quick in lookup once we have loaded all the data. You might be wondering how much data are we talking about. When we look at IRR, we're talking about, it's about 2 million records, plus the same records could be in different sources, and we record that as well. So we're talking all in all about 2.8, 2.9 million records. And well, RPKI, we're talking about 350,000 records at the moment. Then we have ASN data and ASN names. That's another source where we generate a file daily with all the ASN names, and we integrate that directly into the tool. So we also have a very quick lookup, because initially the idea was to rely on RIPestat, but then RIPestat wasn't as fast as we would have liked. And then the main part comes from RISLive. So from RISLive, and you see the same case as with IRR data, we have different, it's not different sources, but RISLive, with RISLive, you can tell RIS which route collectors you want to use as source. And so we can query multiple route collectors at the same time. And then all this data gets fed into the tool, which for every update can give you real-time data about the IRR compliance, RPKI compliance. So it runs checks to see if the network in the update is covered by ROA, if it's valid, if the BGP announcement turns out to be valid or invalid or unknown. And from IRR, it can tell you if there is a route object covering the network, and which source it comes from. So it records those. And so from this, we get, we generate RRD files with all the updates, with all the data about updates. We generate statistics raw statistics that we can use later on. and then we can we generate notifications. So if there's an anomaly, we get a notification. At the moment, it's on Telegram, but then later on, since the system is based on a pluggable system, we could add Slack, we could add anything else. So what data do we produce mostly? The number of updates per ASN and per country, with RPKI status, IRR status, and then the total numbers and so on. And the same we do for the number of updates where the ASN is in the path. So for each update, we look at every ASN in the AS path. We verify the status of the update, and then we generate this data that gets spit out into RRD files basically every minute. And then we could do more. For now, we are generating this, but as we're fine-tuning the tool, we will be adding more outputs to it. So I mentioned we have a sort of a plug-in system, so we can easily add data sources and data analysis. And this was the initial idea with SHMIT, because especially for shutdowns, we want to be able to get the idea that there is something going on, but then we could check it with other sources, with other APIs that can tell us if someone else has seen anything similar. There's good data that we could leverage from it's not KIDA, but it's there are other data sources that we can leverage. And then the idea is also to take everything we have here and feed it into a platform for anomaly detection. We haven't identified the platform yet, but the idea is to take whatever we have, generate our notifications, generate our alerts, generate our graphs, but also feed that data to a system that can help us figure out if there's an anomaly somewhere. And then see how this compares to how we figure it out on ourselves from the tool. And this is an ongoing work because, of course, you need more and more fine-tuning. And I have a question. So, do we see disconnection issues with RIS-Live? We have. So the way the system is built, it tries to reconnect when we have a disconnection, but the biggest problem we've had so far has been it's been not with RIS, but with basically the reloading all the data from the IRRs, because being such a big tree, we have to basically start caching all the data we get as we update the tree, as we update all the IRR data. And then once we have updated that, flush the cache, validate everything, and do everything else. I haven't seen any issues with RIS-Live so far. But it might be that because I just built in capability to reconnect when it disconnects. So probably I haven't seen the issues because of that. But the update for IRR data is every 12 hours. And at the start, when we gather all the data, what we do is we create a local cache of it. So the cache file is about 1 gig, and it's in JSON, and then it has a timestamp. So whenever we start the tool, we verify if the timestamp is older than 12 hours, and if it is, we reload the data. Otherwise, we trust the one we have in the system. Okay, so I was saying that we still need to do some fine-tuning. So here are some of the requirements that we have. It's about 2 cores. We've seen that with 1 core, sometimes there will be some lag in the checks of the validity of the prefixes. The culprit is RAM. 16 gigabytes is the minimum because refreshing the data from the IRR, because the problem, as I said, is that if we have to so if when we refresh the data, we just create another tree on separate tree, and then we just overwrite the previous one. So that is the biggest issue, because you have to have two separate trees at the same time in memory. But we've seen there's no need to go over 16 gigabytes, and of course you need decent network connectivity. So what is about the future? Fine-tuning, as I said, adding additional sources of data, and we'll talk about an additional source in a moment, and then opening access to the code repository on GitHub. So, okay, there's another question. How long have you been working on this? So, yes, did we start with the final idea in mind, or did that emerge from the convergence of multiple smaller products? The idea was to have a tool that would look into BGP updates and gather some data out of them. The validation was another path, but then the problem that arose pretty quickly, and I can connect with a question from Thies about using an RTM for IRR. Using an RTM would solve the problem of getting the data, but then how do you have it in memory for the quick querying is another path. You would still have to create your own internal data structure. So that wouldn't solve the problem we have. So the question, the problem that we've seen, Sasha, is more about the intention to use external data, just using API calls at the beginning. And those have proven to be too slow for the updates, the number of updates that we see coming in from BGP. So it took longer than I expected, but for two reasons. One is that exactly the initial idea was to use APIs, but then everything was moved to be done internally. And then because the tool I'm showing after this is going to use the same exact libraries. So as I was developing both at the same time, I preferred to spend time working on getting good libraries that would help us, and that would be able to be plugged into the two separate tools. So when I started, the idea was to get exactly this, but then a lot of time was spent in making sure we got data internally into the tool, so as to avoid relying on external data sources. Does this answer your question? And actually, this was my last slide. You're welcome. This was my last slide. And if you have additional questions, you can find my email address, Telegram, Twitter and Telegram, all in this order. The ASN and data name is also built from the IRR, but it's data that we merge from different sources. Yes. And you're welcome. Okay, thanks.
Awesome. Awesome, Max. Thanks for showing us or giving us some details about the SHMIT tool. We hope to show you some real demo next time we meet again. So next is the route collector tool that we have been working on, and it's still Max that will tell us a bit more about that.
It is still me, but the two talks are connected because, as I mentioned, the two tools share libraries and share the basis. So the same concept that applies to SHMIT for lookups or data collection applies to this. So what's the different issue here? Manus's action 1, filtering, needs constant attention. Filters change, you have new BGP sessions, new peers, new transits, new topologies. But at present, we verify it when a member joins, and from time to time, there's a manual check that's applied. So from internal discussions, we came up with this idea. Let's try to automate the way we check for compliance. So amongst other ideas, the one that I came up with was, let's build a route collector system, because then we can ask participants, members of Manners, to peer with this route collector system. It can be as simple as just one route collector for the whole world, or hopefully we can make it so that it becomes a distributed system. It will depend on how it works, the budget that we can allocate later on to it, because setting it up would be easy, but we have to make sure in the long run this can be managed and this can be sustainable. So the idea is to ask members to peer with these route collector using the same exact filters they use for all the other IXP sessions. So standard filters, nothing that's specific for this route collector. Use the same as you would use for any other peers. And this will give us data that we can show then in the observatory, and we can use for helping members understand how their BGP sessions are set up. Or the idea is that we would be able to pinpoint if there's a mistake in your filters, in the members' filters, or anything else. So I have to focus. This is based on ExaBGP to get the routes, basically the BGP updates. And we use the same base libraries as SHMIT. So we verify the IRR, RPKI, and then additionally we have the ASNs, the customer cone, and we link to RIS to get another point of view and say, do we see the same exact routes we see in RIS, or is there any difference between what you're announcing here and what we see in RIS? Because maybe you apply different filters, or sometimes people don't apply any filter to what they announce to RIS. So this way, we can provide comparison in the data that's seen in our root collectors and in RIS. And then the idea is that we can also feed. We've started discussion with RIPE-NCC. We can also feed our data to RIS Live, so other people can do more analysis based on what we see. So what data we generate? Compliance with the Manners Action 1, filtering, as I mentioned, and any anomaly detected, we can show it in the observatory. And then we might, in the future, also implement alarms. So something that sends you an email or notifies you in another way when we see something different from the point of view of the route collectors. So what is the present? I'm refining code as we speak, so in this exact period, and starting the first trials in mid-July, hopefully, and then opening it as public maybe in August. But then the future is making it becoming a production service before the end of the year, and adding more real-time features, so more real-time checks, more data that we can generate from the data we gather from these updates. And then we're open to more suggestions. So if you have an idea, if you think, oh, while you're doing this, can you implement this other check? We're very open to suggestions. So more than happy to listen to what you can come up with as ideas here. And this was a very quick talk, but there isn't much to say here. And I have a nice question from Mingwei. If we are producing raw MRT dumps, no, I haven't thought about that for now, but that's a good suggestion. So thanks for that. I'll take a note and maybe implement it later on. So thanks. Any other questions?
Maybe a question from me, Max. Will it support BMP? Oh, there you go.
Ah, there you go. No, I haven't thought of BMP either. The reason is everything is based on ExaBGP. So I was thinking when I was answering Mingwei, when I saw Mingwei's question, I thought maybe we could also use some other tool. But then I will think about that. Yes, that's also a good question. Thanks.
Do you have any more questions? I don't think so. If if not, let's move on to the next one. So, which is my turn.
Then I can say goodbye and sorry for the two talks, one after the other, but enjoy the rest of the
Let's
session.
stay here. We might have more questions for you. Great. Max, would you? Yeah, thank you. Great. Yeah. So now we are going to talk about a tool which we name ROBAC, because we sometimes need to roll back to see historical data on RPKI, but the real idea is a historical explorer for ROA data. So how this all started? Of course, we for troubleshooting any routing incidents, we sometimes need to go back into the past and see what were the ROAs created and when they were created. Sometimes ROAs can be short-lived, so you might not actually see them on the repositories. And for this, we have the RIPE NCC, which is providing a very nice repository called a RIPE RPKI archive. As you can see, you have the FTP link to the archive. They have been collecting actually the data from day one, from all the trust and collocators, the Afrinic, Epinic, LACNIC, ARIN, and RIPE and CCTAL themselves. So we have the data there. So the data are in I would say in two different formats. You have a CSV file which lists all the VRPs, and then you have the tarballs, which contains the actual ROAs and all the associated RPKI files such as CRLs and manifests as well. So for this tool, what we have been doing is we collected the CSV files from the RIPE archive, and then we actually inserted them in a Postgre database, on top of which we have added a REST API. So if you want to have a look at how it looks like, I would invite you to navigate to tinyurl.com/robac, and you will have the graphical user interface, which we have developed quite recently, but we haven't put that into production yet, but that's coming soon. But at least you can have a look and try to play a little bit with it. So it is powered by a REST API. So the REST API is, as you can see, linked to the docs is on my screen. So right now there is only one function, which is the search function, and you can search by prefix, and you can also search by ASN or both, depending on what exactly you want to get. So the prefix, the way it works is that you put a prefix. So basically, you want to search for any ROA that is covering that prefix. So this is just an example of the previous request that I've put on the slide. So it gives you 2 ROAs, for example, for a request that I've just made. And it gives you the ASN and then the IP prefix as well as the max length. And most importantly, the not after and not before time, which is also which is what we are interested in, because we want to see whether a ROA has been covering a prefix at a certain point in time. So as I mentioned, so what we are currently doing is collecting the CSV records from the RPKI archive tool, sending it to a Postgres database. So we have quite a large number of records, more than 4 billion records. And then using a simple API, we display the data based on the search parameters. What we want to do now, so right now we only have data, I think, as from 2018, because before that, the structure of the different trust and collocators of different RIOs, and namely for Epinic, was a little bit different. So it was difficult to get the data from day one. So with a bit of more coding and more, yeah, we need to work with the data a bit more, we can actually incorporate all the ROAs from day one. So I think it's starting in 2010 or 2011. So that would be quite some amount of information. And yeah, one thing we are not doing right now is to extract from this repository at what point in time the ROAs are revoked. So right now we only have the time at which they were created, but not the time at which they were revoked, because basically the CSV files in the repository only contain the VRPs. So the way to do that is to actually go into the tarballs, get the actual ROAs, and see at what point they disappear in the repository to actually infer at what point ROAs were revoked. And finally, I think some visualization would be great. So this to have a visual feel of, for example, if you have a prefix and at what point in time it was covered by a ROA or not actually. So that's what I have for this very small tool, which was rather easy to build, but that's thanks to the great work that the RIPE NCC has been doing, collecting all this information and providing it to the community. Thank you. Happy to take questions if there are any. So if a ROA gets its not before date updated, will you still have the old date? So the way it works is that whenever there is a new ROA, so basically a ROA cannot be updated because it is a signed object. So whenever there is any change on a ROA, actually what happens is that there is a new ROA that gets created in the back end. Maybe on the front end, depending on the RIR with which you are working, you might see actually an update of a ROA, but actually what is happening is that there is a new ROA which gets created, and this new ROA will just appear as a new VRP in the file. So it will show as a new ROA in the historical repository. Slide 8, can you repeat again to explain, please? Okay, slide 8, yeah, this is just our workflow. So we have the FTP repository. So you can go and have a look at how it looks like. It looks like ftp.ripe.net/RPKI. So you have the different tals, which are the trust anchor locators, under which now you have the different ROAs classified by dates. So we navigate through each of those repositories and then download the CSV files. We read them, and then we extract the information we need and we put it in a Postgres database. And then using just a simple API, so in our case, we use a Flask API, we read the data from the Postgres and we make it available, in our case, through the API and through also a graphical user interface. That's it. If a new ROA is issued that has the same tuple replacing an earlier one, does it answer the question, was there a ROA covering a particular time, which you described as the intent of the data source? So if a new ROA is created with the exact same information, that's not too much of a problem. The only thing it will be on the time scale, it will be just a more recent one, I guess. Normally, you wouldn't create a ROA with the time in the past, though it is possible, but normally you wouldn't do that. I don't know if that answers your question, Tony. Okay. So in that case, I think I'm done with this presentation. we can go to the next one from Mingwei. Mingwei, over to you.
Good day. Great talk. Right. Let's see if I can. Share screen. Okay. You guys see the slides, hopefully. Right. Okay, so I'm going to introduce some of my work, BGPKIT, and then what I've been doing on the side of BGP and MRT and RPKI data processing. And then this particular talk will be focused on the Python binding of BGPKIT, which is called PyBGPKIT. A brief overview of what I've been working on under the BGPKIT umbrella. There's the main goal is to build some more modern, performant, and open source BGP data processing tools. There are quite a few tools that are existing and it's very good, but they tend to be written in a language that are not so modern. And then for me, it's like C-based tools are not workable for me. Yet I am really terrible at C coding, so I wanted to do something that is some alternatives. And then there's not enough there, so I started building things like that in Rust. Everything is open source under the in GitHub, and it's a personal project that turns a little bit more serious over the time. So there are a few ones that are to be introduced first. BGPKIT parser is the main one that focused on parsing MRT data with Rust code. It's basically a designed to be alternative to Rust-based solutions to other good projects like libparse BGP from Candela, or under the BGP stream umbrella, and BGP dump from RIPE, BGP scanner from SLRio, and also micro BGP straight. I'm sorry, I didn't get the name there. I only know that they're currently hosted at the Spot 14 CodeForge. There might be some others that I missed here, but it's basically yet another tool for processing MRT data. It's designed to be performant and then also designed to be easy to extend and compose. So that after I'm building this, I started working on some other codes that are just based on it. So it's like a good foundation to use. Another one that is a bit more lightweight is the metadata information broker. It's basically indexing publicly available MRT files so that you can search with Python binding or RESTful APIs for all the files. We don't need to go to those locations. BGP stream from Candela does that as well. This is basically trying to duplicate that work and then be kind of a building as a Rust-based solution as well. There's no, it's basically reinventing the wheel there. The BGPKIT ROA is a very similar tool for as comparing to the tools that Amreesh just introduced. It uses the same data source from RIPE-RIS, and it's a little bit different. You can take a look. By the way, the slides will be sent over the chat soon. The documentation is pretty clear there, I think. The key kind of questions that I want to answer is that what kind of prefix did Google have RPKI last year? So search by ASN, and other things like how long has this prefix been on RPKI, and since when has it been registered on RPKI? So it's time-based questions, and also is this the prefix origin pair valid based on say today's data, or say a year from now, or a year ago, or 10 years ago? Is that, I'm not sure that's valid. Anyway, so it's it can look by prefix years and pairs, and filtering by time as well. And then there are a couple of other things that I built over these few months. There's a BGPKIT peer stat. This is a collaboration with IJ, Romain Fontaine. It's a daily summarization of BGP peers for ROPUs and REPRIS. REPRIS already provides a really good peers API there. This is just more like a personal interest that I wanted to have everything put together. And this also provides a daily archive. So if you're interested, you can go to their link. I'm hosting one daily archiving site as well. And then it's been running for a few months. What it provides is to have a list of IPS and for each peer that the ROPUs and REPRIS connects to. Will provide the IPS and like how many other ASNs are connected to the peer, and then also the READ4 and basics prefix count. And the main usage is to basically determine what peers are full feed, but there can be other use cases as well. There's a value-free BGP propagation simulation. The big assumption is that everything follows value-free, which is probably not true in many cases, but it's just for fun. BGP model is a base Rust crates that defines other concepts. If you're interested in building some other tools with Rust, you can go use that as a base crate. And finally, the PyBGPKIT and then PyBGPKIT API, which is the thing that I want to present today. It's basically a kind of all-covering Python binding for everything that I did. Not everything yet, but the main things like the parser, the broker, and the ROA lookup. It's a Python binding, and it can be run. And the API is the kind of the RESTful API for using that Python binding. It's the thing wrapper using a fast API. It has a little bit logic on parallelizing parsing multiple files, so it can be run extremely fast if you have a beefy enough setup. I'll talk about that in the later slides. Okay. Right. So PyBGPKIT. It's a Python binding for Rust, and it has 3 included kind of functionalities for sub-libraries that are ported over there. It's not a complete port. It's using the Rust kind of built binaries. So it still should be close to the performance of the Rust of the binary, especially for the parser. And then and there's if there's any updates on the parse, the Rust library, the base library, the Python binding can be easily updated with the synchronization. The goal is to allow easy access to also, again, publicly available data. It's open source. And one of the key features that I personally use, and also at work, is that I want to do like a analysis on BGP events happening on the internet. For example, if I see a raw leak or a hijacks reported somewhere, I can directly run this library on a Google Colab, which is the online Jupyter notebook provided by Google, or any personal like Jupyter notebooks on your own laptops. So, and then do a quick analysis. And here's an example that I want to show. Oops. Sorry, I think I've stopped sharing. Okay, so hopefully you guys can see this. You folks can see that. So to install this package is rather simple. This is showing a online Google Colab Jupyter notebook. You can basically run this command here to install it. The escalation mark is basically tells the Colab to run a shell command. So you install that and then import it. It's as simple as that. Let me see if we can do it. So it's allocating a new instance. Yeah, so it should be as simple as just 2 commands to begin to use that. And for parsing single files, so you can do something like this, where call BGPKIT .parser. And the good thing about BGPKIT parser is that you can basically provide it any link you want. as long as you can connect it to it. So it can be a remote or local. It can also be a BZIP file or gzip. So it covers all the file formats from Cypress and Proteus. And then for the URL, so this can be also provided like a local path if you want. And for the filters, that's there's a complete list of filters on the GitHub repo. Yeah, but for this one, you can see you can filter by a specific peer, or actually multiple peers, and then you call it parse all to get all the messages. And after that, you can do a little bit of kind of filtering by yourself, or do some Python logic. Here, what I'm doing here is basically simply do a count, or actually not, just printing elements or printing messages, and then printing the type, which is a withdrawal announcement or origin essence. And it's only count the top 10. But if you want, you can do more complicated stuff there. For example, if you want to see the whole message, you can do this. You can parse it again. So the complete message contains a lot of information. They're encoded as a JSON, as a Python dictionary. So many things you can just basically call, fetch the dictionary fields there to get the information. So that's parsing. And if you want to search for available files, you can create a broker instance, not instance, like object, and then extend a query there. So the main parameter is like TS, timestamp start and timestamp end. You can provide it with a Unix timestamp or a standard time string. This is the only kind of format that it accepts in terms of like a non-Unix timestamp, which is pretty standard. I forgot. It's a RFC 333, I think. Either way, so when you do that, you basically ask for, give me all the files that are archived in this time range, and then print all the items. So what you can see here is basically, let's see if that works. You get a list of files. Each file or object contains the timestamp, start and end, a collector and data type, and a URL there. So you can, and also it contains a rough size. The size is estimated from the one that they're putting on the website. So it's a rough. So it's like if you get a 3.4 M, you get just translating to 3.4 megabytes and then turn it into bytes. So it's not exactly correct, but it's close enough to use as an estimation. And then lastly, there's a check historical data, RPKI. Should be faster. You can do things like this, where you look for like our ROAs from this ASN, and then you give it a timestamp. So you can say what's the available, the ROA entries for is 333 on this particular date, and then it will print you a list of ROA entries. It contains a prefix, AS, and the max length, and also the date ranges that this particular prefix is being valid for. And it actually contains something like time range in the future, because we don't filter with that. So you can see that last time it was valid July 2nd. It should be updated to that fix. So this data is updated daily. So you see the last timestamp here is saying that when was the lastly available on RPKI. It only goes to today at most. So there's some drawbacks on doing that, but we can discuss it in offline. So lastly, for PyBGPKIT, there's also API that I've been building. It's a wrapper around the PyBGPKIT. So you can see it contains three different files, three different endpoints. So the parse is parsing a single file. For example, this one is a very huge one. It's 1.5 gigabytes MRT dump. Let me show you how it works. And you can filter by, say, ASN. No, let's not filter that. Let's just keep type a limit here. So top 10 messages. And then you can go ahead and tell it to parse. And then what it does for returns is it returns you the number of messages. So because we're limited by the message by 10, so it's only returning top 10 messages from that big file. And it also stops parsing once it reaches the limit. And it also returns you what files has been used for producing the messages above. So that's a single file parsing, and then similar things for files. It's searching for available files. I'm not going to show it here. You can try it out later. You can deploy that instance on your own. And then lastly, so the search is a comprehensive one that combines searching and then parsing for multiple files. So for example, here's an example where I want to show what messages available or kind of appeared in the YouTube 2008 prefix hijacking event. So I know that timestamps this. And I think I also, oh yeah, I need a prefix. Let me see if that, okay, here's a report. I also know that there's a prefix that's involved here. So I put it there as a filter by prefix. And I want to reduce the parsing by only using one collector. So using RC00 for that. And then limit by, so show me the top 100 messages on that, and then run it. So what it does in backend is that it search for all the MRT files available, matching the timestamps. And then also, and then for each one, it starts a separate instance, separate thread to parse the file and then do the filtering. And it returns out the message. So although we limit by 100, it only shows up like 47 messages involved in that prefix. Here's all the messages and all the files that's being parsed during that time. So I think it's about, 56 files parsed for this particular query. And it's pretty quick, if you can see. And you can also say, I want to include subprefix. So if I want to see what's being kind of or counter hijacked by Google, you can include subprefix. So in this query, we'll get 47 messages returned. So if we include subprefix, we should see more ones. There should be 57 messages. Yes, so that's like 10 more messages that are subprefix of that. Okay, so everything, sorry, I didn't put a link here for the code. I'll put it there and then share with everybody. This code is publicly available. You can run it. It's a fast API instance. You can run it on your own laptop. The more cores you give it, the better, because it's a very computationally intense. But other than that, I'm happy to take questions. And thanks. Oh, okay. I don't see any questions on the chat. Yes.
I don't see any questions yet. If not, I have one for you. Can you explain a little bit what's the role of the broker?
The role of the broker is basically to provide a unified interface for you to search for available RT files. Right. So if I want to parse all the files available for a particular time range, I can just go to the broker and then it will give me both the files from Repris and from Rockwheels. And then it's designed to be extensible. So if we're having, actually, I'm in process of working with PCH to index their files. So hopefully soon we can get also the PCH files returned as the same query. Thanks, Jeff, for the link. Yes, that's the API. And also thank you for ISOC for sponsoring it. It's part of the collaboration with ISOC. And I'm really appreciate the help there as well. Thanks,
Mingwei. Yeah, I can testify on how fast the PyBGPKIT API is, because if I'm not mistaken, Mingwei, the multi-threading is happening on two sides, on the BGPKIT itself and on the API as well. Is that correct?
Sorry, what was the
So the multi-threading, the multi-processing to speed up the search of the files.
Yeah, kind of. The BGPKIT parser itself it's not very parallels. For this particular one, the main parallelization is done at the files level. So if you have 10 core machine and give it 50 files, it's going to use all 10 cores to parse like 10 files at a time, and then kind of getting a queue, and then new files getting into the queue and get parsed. So yeah, but parsing for each file is relatively single-threaded because I haven't figured out the way to parse a MRT banner file in parallel yet, or for a single file.
Great, thanks a lot, and thanks for joining that early for you, Mingwei.
Yeah, sure.
Okay, thank you. Sure. And our final talk today is from Massimo Candela, who is joining us. So Massimo, over to you. You can quickly introduce yourself if you want.
Yes, perfect. So first of all, do you see the screen correctly?
Yes, perfect.
So perfect. Well, my name is, first of all, good afternoon, everybody. My name is Massimo Candela. I'm a senior software engineer at NTT, and I work on the automation and monitoring of our global IP network. I'm also a Manners ambassador for the research field, and the presentation of today is going to be a really quick presentation. I like quick presentation, and it is a quick presentation about like a review of 1 year of RPKI operations at NTT. It will include some numbers, also numbers of mistakes that we did, and it will include also some generic numbers about the global internet. But let's start with some facts. So NTT started doing route origin validation in March 2020. And route origin validation means that basically we started rejecting RPKI invalids, and together with creating ROAs are usually the 2 steps that they are defined as like the deployment of RPKI. Unfortunately, a bit less documented is the effort that is needed to keep your RPKI deployment healthy over your daily routing operations. This is because it requires additional knowledge, but also it requires additional procedures. We will see a bit what I mean with this. But imagine that you are an autonomous system, that you are doing route origin validation. You are also creating your ROA, so you are definitely RPKI aware. But still, occasionally, you announce RPKI invalids. And this is what I'm talking about. So in this slide, when I say mistakes, that basically I'm referring to RPKI invalid announcement that they just happen involuntarily. For my experience, usually the main 2, I would say, cases are like you want to announce a prefix and you forget about RPKI. Or maybe you didn't forget about RPKI, but you didn't, you postponed the creation of ROAs, for example. And this error is, basically, this is based on sometimes the misconception that since it's a new prefix that you are announcing, then it's going to be unknown while you do route origin validation. But did you check? So before start announcing, did you check that it's going to be unknown? Are you sure? Because if there is another ROA covering a less specific prefix, then what you are doing is you are announcing an RPKI invalid, and it's not really uncommon. Another case is when you know about RPKI, you didn't forget about it, but you didn't consider the timing. So there is a publication time when you create the ROA and this to be available in public repository. And there is also an intrinsic propagation time, which is essentially the time that is needed for the other players of the internet to do another RPKI validation cycle and download the new ROA definitions that you created. Now, We will talk a bit more in details about this timing in a bit, and but let's go back to NTT. So the review of what NTT did. I reviewed an entire calendar year, 2021, which is a year where we were already doing route origin validation because we started in 2020. And what I did is that I collected all the alerts generated by our internal installation of BGP Alerter, which is an open source tool that does RPKI and BGP monitoring. And we will talk about this in a bit. But in addition to the alert, I took also all the tickets related to these alerts that they were opened by the NOC to address the issues. And my goal was essentially to find in the tickets the cause of it. And I managed to basically to identify 3 categories of causes. Well, the first one is the one that I was talking before, is essentially the max length issue. A new prefix is announced, there is a ROA, but the max length is wrong. We are announcing an invalid. The second case is when we want to announce a prefix of a customer because we have an agreement with the customer. But the customer has other ROAs for his own IS or other IS, it doesn't matter, but it does not have ROAs for 2914, which is our autonomous system. And so, again, RPKI invalid announcement. And you may say, well, that's a problem of the customer, but I don't really agree with that because essentially it shows that there is space for what I was saying before, new procedures, procedures that they include a better communication with the customer. Third case, we migrated prefixes from one autonomous system to another, but we didn't properly update the ROAs. Okay, so we didn't properly do it, or we didn't do it in the proper timing. We had 71 of these cases, and which are not, it's a small amount compared to the number of operations that we do per day, but we wanted to address them. And plotted in this pie chart, you can see that that basically almost 60% is the max length issue, which I was expecting. And the second by percentage is 25.5, which is a migration of resources of prefixes from one autonomous system to another. And last one is almost 17% is announcing of customer prefixes. Now, in this presentation, I'm not going to talk about details about the solution. There is a presentation I did in RIPE 82, where I presented our technical solution, so the software, and this software is, most of it is open source and you can use it. We are going to talk in a bit. And this was in RIPE 82. In RIPE 84, instead, I presented more details about our internal procedure. So essentially what we did is a technical solution and a procedure that we have to follow. And the technical solution is mostly monitoring. I just give you an example. We have to start announcing a prefix of a customer. We type it in our system. The monitoring says that the customer does not have a ROA. We engage in a communication with the customer. The customer at some point creates the ROA. Our monitoring gives us a feedback back that the ROA is visible and that we have a green light to announce. This is just one of the possible examples. So I'm not going to discuss further, but I want to give you a quick overview of the results. The 26th of March 2021, we put into production this technical plus procedure, and we got a reduction of 87% of RPKI, involuntary RPKI invalid announcements. As I said, not a lot, they were not a lot, but we really try hard at NTT to do the best that we can. And so this one was one of our focus for that year. And you can obtain a similar result, and I show you how later. But now let's go back on the timing part. And so imagine that, so as I said, there is this publication and this propagation time. And you may say, yeah, I mean, who cares, right? You create ROA, at some point they are going to be valid and everything is okay. Well, I do not agree with this because, well, it depends really on you and what you're doing with those prefixes, what services in those prefixes. But if you are, for example, managing prefixes for a large CDN, you cannot really say, oh, for a couple of hours, you're going to be, in the best case, the routing is suboptimal. In the worst case, you are going to be unreachable. It does matter. It does impact a lot. But even if it doesn't matter in your specific case, how do you define that everything is going to be fine? How do you define transient? How do you know that it's something that is going to be RPKI valid at some point and that you didn't screw up something if you are not monitoring? So in particular, what I am expressing here is representing this quick chart where this is not entity data. This is the entire ripe risk data. And I took all the data, and here I'm plotting only the invalid RPKI announcement of 2021 based on the wrong max length, only wrong max length in this image. And with a 1 month window, you can see that basically 40% they get resolved in 1 day. 1 day is the granularity of the chart, so it could be 1 second or 24 hours. It's fine. But what is not fine is the fact that the remaining 60%, they actually get resolved in more than 1 day. And we have almost a 15% that they take the entire month and then maybe are still invalid as of today. So the thing is this, so we can say that there is some data that maybe some data impurity in it. We can say that there is some malicious intent from some other actors. That's fine. But on the big numbers, we can probably conclude that there is a high chance that a lot of these are actually operators that they are not monitoring and they are not aware that they are actually doing RPKI invalid announcements. But let's go how we address this and how you can address this. So BGP Alerter is an open source solution that does BGP and RPKI monitoring. You can download it in this repository. We are using it for over 3 years now. In production, it's based for a lot of operations that we do. And together with us, a lot of important organizations. There are more than 300 installations worldwide. We have basically almost all the big players and also some governments that they are actually using it. So you can also benefit out of it. It requires not a lot of resources. At the moment, with 2 gigabytes, you can do it, and you need 1 core, but it can spread also on multiple cores. It does not really matter. So it requires really a small amount of power to run. But the most important part is that it is easy to use because it's a binary that you just download, you run. It's going to ask you the autonomous system. You type the autonomous system, and that just works because it's going to do auto configuration. It connects to public repositories of data, and it does basically, for example, the RIS project, and you don't need to feed your own data. So since we are also in a research track here, it can be used for research purposes because actually was also designed for that. It solves a lot of scalability issues because there are a lot of data that they are coming from RIS, and it's absolutely not a joke to handle that, and offers some module. So basically, all the monitoring that is done are separated modules, and you extend already the class, and you can basically inherit all the all the asynchronous part or the scalability part. You can implement just what you want to monitor, and the rest is done. So I did an in-depth presentation during the math working group in RIPE 83. But this is not the topic of today. But anyway, so in the end, for just as without research, just that you run it as it is, you will have BGP monitoring with hijack detection, visibility loss, path monitoring. So the entire path, you can also specify your own conditions, but you have by default also upstream and downstream monitor. So you will get, for example, alerted if a new upstream or new downstream that it was never there before, it appears in an IS path. And has, of course, RPKI monitoring. So you will get notified for the RPKI part if your autonomous system is announcing RPKI invalid prefixes. If it's announcing a prefix that is not covered by a ROA, you can disable all the alerts. If you don't like some of them, you can disable them. You can get notified if a ROA covering your prefixes disappear, which sounds strange, but actually it does happen. It could be one of your colleagues that just did an error, but more probably it could be also that there is a malfunction in the public RPKI architecture, like the one that happened to ARIN in 2020 when ROA started disappearing. Or you can also have like, and I think this is possibly the one that I feel is the most useful to my operations, is like getting notified for every changes that is impacting any ROA for any of your prefixes or autonomous systems. So basically it gives you a diff. If it's added, deleted, edited, whatever, a ROA, you get a diff. And for example, it helps you to have a look on that publication time that we were talking before. So you create a ROA, you change the ROA, and you get a feedback back when this ROA is finally visible. Or you can put it in a Slack channel, and if your colleagues, they are like doing changes, you have a channel with all the diffs and you are all in sync in what's going on. You can get notified for trust anchor malfunction, and this is actually really interesting. We created some specific monitoring already integrated for trust anchors, because trust anchor malfunctions, unfortunately, they do happen kind of regularly, and you can find at Live 84 a presentation I did on all the, in the last 2 years, malfunctions that they happen with all the details. And this would allow you to do two things. One, first of all, to basically be aware of what's going on around you while you are operating. And second of all, it will maybe save you also some time in not debugging things that they are not related to you. So you already know where to refer. And last, you get notified when ROA are expiring. ROA can expire because the ROA expired itself, or a certificate that is in the validation chain. Like, for example, it happened with the JPNIC issue in 2022, where a disk full was basically preventing the update of certificate that was basically making expire a bunch of ROAs under. And this expiring mechanism is also thanks to another open project, really amazing. It's RPKI, OpenBSD RPKI client, which is an RPKI validator that you can use, and exports a lot of metadata about ROAs, which are really useful. And this is an example of Slack messaging. You can receive it by email. You can receive it on Teams. You can receive it on even on various apps. You can connect to an API directly. Has at the moment already implemented a big amount, more than 10 type of chats, and you can connect with all sort of API, bot, guest, and post, and things like this. So you will definitely find a way how you can get notified easily. And my presentation is over, and thank you very much for your attention. And if you want to contact me, this is my email, or you can just follow me on Twitter. Sometimes I share things about, well, these topics. Thank you very much.
Thank you, Massimo, for this great talk. I hope you got an overview of the BGP alerter and how useful this tool can be. We would actually encourage operators to actually use this tool because it can become very handy in terms of monitoring your RPKI ecosystem. We have a question. Maybe Massimo, you can take that. How different is BGP alerter to Artemis?
Sorry, can you repeat the question?
How different is BGP alerter or any other tool to Artemis?
Yeah.
Mm-hmm.
So, well, first of all, I think we need a plurality of tools for solving problems. We don't necessarily have to have one tool for it. The main difference that I see between BGP alerter and Artemis is that BGP alerter is more focus on the, let's say, monitoring during operation. So the Artemis is mostly hijack detection, at least for last time I checked, and for what not, it's really focusing on hijack detection, while the creation of BGP alerter was focused mostly on, not on monitoring only what other actors are doing with your resources, but monitoring your own operations, because at the moment, on the internet, there are a lot of players. They are doing routing, but they are not at all monitoring themselves. So let's face the truth, the majority of incidents are just mistakes. So they are not there are these big hijacks, and BGP alerter also monitors for that, but the majority of incidents are typos, are leaks, are all things that basically are operational faults and things like this. And BGP Alerter was designed with that in mind. So you monitor yourself and you get real-time informed about your errors, and also includes the Hijack, and it gives you an overview of path monitoring. So not only the origin can monitor the entire path, it can give you a lot of things. And another thing is that you can, it's a binary, you just run it, it just works, and you can integrate it with your classic tool like Nagios or whatever you want. And that was also another thing. But this is, I think every tool has pros and cons, and this is mostly what I see for BGP Alerter.
Great, thank you, Massimo. What else do we have? I think Tony has asked a question about invalid max length. So would you consider a different indication if an invalid max length violation is covered with a valid route with the same AS path? I think
I'm not getting the question, I'm sorry.
This is referring to routes which are marked as invalid because of max length. So would we consider this as a functional problem? I guess as he mentioned himself, it is good to be aware of routes that are getting invalidated because of the max length problem.
So I honestly did not get the question. So the question is if the max length, it is an operational problem or not. The max length, it is an operational problem for various reasons. First of all, is because basically if you are defining in RPKI that must be the max length. First of all, the first question is that you can really not trust the AS path in none of the case. So, I mean, there is a lot of AS path manipulation that can happen. And also we know that the max length, one of the features is exactly to avoid that. So you should create a max length that is exactly the same length of what you are announcing. Otherwise you leave a gap for other actors to do malicious intent. But I'm honest, honestly, I did not get the question. So if it's there, if you can rephrase it, otherwise we can bring this offline and if there is okay, but if there is if a max length error happens, it means that the route is not valid. Max length will create an invalid RPKI, it will get rejected.
Tony, feel free to jump on the mic and ask your question directly if you wish.
Yeah. All I was trying to say is that there's, you know, it might be a more specific that's leaking out that is unintentional, but it isn't functionally causing a routing problem. It might be indicated differently than the other.
Yeah, but I mean, if a more specific leaks, what happens with the alerting that we are doing is actually you get informed that is visible from multiple vantage points in the network. So what you want to do after with it is up to you. Actually, the fact that it should not have been leaking and it leaked, it's a good information that you get that. It doesn't necessarily mean that you are get it impacted on the routing level, because if it was not supposed to leak, then fine. But at least you know, and I now understand what you mean. So you were mostly referring to the RIPE RIS data, the one that shows that basically some they don't get resolved ever. Yes, maybe it's not impacting the routing, and probably that's why they don't discover it for more than a month. But still, at some point that should get clean, or you don't export it, or you create the route for it. It's useless to export it and being invalid. Okay. So in my analysis, I didn't do this distinction. I just said, this is invalid. Let's see how much time it takes for them to become valid. And the fact that it takes a month, it shows that, yeah, probably it was not impact. The thing is that sometimes it's not, it's maybe impacting the routing, maybe it's not a leak, maybe it is impacting the routing, but it is also, since RPKI at the moment is not deployed everywhere, it is impacting partially, and the visibility is more or less there. Maybe it's just doing a longer route or whatever, and nobody notices it. That's also a case.
Okay, thanks.
No, thank you for the question. I'm sorry that I was not getting at the beginning.
There's another question from Nick. Massimo?
Yeah, okay, I see the question. Yes, it is possible. It is possible, and basically there is already a method that is able to handle third-party asynchronous query on that. Of course, it depends what you want to monitor. If you want to monitor your own AS paths, I think it could easily scale. Otherwise, it could be. But you can. It's mostly. It can be done. It's mostly. I would say how, but it is already implemented. Architecture that would allow you to do that.
Awesome. Thanks a lot, Massimo, for your talk and the presentation of the tool. So this brings us to the end of the set of presentations. Thank you all for your kind attention. But before we go, I just wanted also to present you the current Manus Research ambassadors and fellows. And we have Massimo, who is online as well, who is one of our ambassadors. He's working together with Romain. And we have currently two fellows, Joanna from Simula and Zubair from MPI. And they will be working on two different projects. So Joanna is working on an analysis of the remote triggered black holes prefixes. So and yeah, on top of the research fellowship, what we have, we are also working on external projects with the University of Strasbourg to detect type 1 hijack. So just to give you an update, so besides all the tools that we have been working on, we are also doing a few research studies, as I mentioned, and one of them actually Massimo hinted on that, the propagation time, how much time it takes for between the creation of a ROA or a deletion of a ROA and the impact of BGP, because that's important for your operations. So this is a project that we have also been working on, and hopefully next time we meet, maybe for the community week by the end of the year, we will have very good results to show. And this brings me to the end of our session today. We have seen a few presentation on tools, and I hope this was interesting to you. So if you have any questions, or if you're interested to participate in any way, just send us an email, contact@manus.org, that would work. And if you have any questions, so our presenters today shared their email addresses and contact details. You can also reach out to them. And yeah, stay tuned. So have a look at our Twitter feed on the new things that we will be developing and pushing out into production, and let us know how helpful these are to you. Other than that, I think we're done for today. I would like to thank you all for your kind attention, and don't miss the RPKI tutorial, the second part of it tomorrow, starting at
that is 6 UTC.
6 UTC. Thank you, Massimo.
And it's not the second part. It's not the second part. It's the second iteration. So we'll start
second
from scratch.
iteration. Okay. There we go.
Well, thank you, everybody, and talk to you tomorrow.
Thank you all. Bye-bye.
Please.
Recording stopped.